Welcome, everyone, and good day or evening, depending on whatever part of the world that you're coming from. I would like to welcome you to the second edition of Spotlight Talk, Alumni Success Stories. And today we are having with us Ahmad Albar. I hope I pronounced your name right.
Correct.
So Ahmad is a cybersecurity data scientist. He's pursuing his master's in data science from the University of Illinois. And his area of interest is actually safe utilization of LLMs. And he's done quite a lot of open source work in that area. And today he's going to present a very interesting topic, which is LLM agents. It's a trending topic. And he's also going to shed light on graph theory and how it can be used to enhance LLM workflows. So at PySchool, just briefly, we do many of these tech talks, which highlight up and coming, alumni like Ahmad, as well as renowned industry experts. So stay tuned. I urge you to follow our social media for any other future tech talks like this. And without further ado, Ahmad, I give the floor over to you.
Great. Thanks for the detailed introduction. Before starting, just I want to ask a question like how many here attended PySchool before or didn't attend PySchool? Just to be a fun intro about this. Okay, one raise their hands. If you don't know how to raise your hand, you can also write in the chat. Cool. Yeah, the majority already part of PySchool. Great. So I joined PySchool in 2019. It was one of my first activities with data science. It's interesting program. I used to be developer at that time, but now I switched to data science career path. And I will talk about the graph theory to orchestrate language models and also to represent the data in better way to get a better result from the language models. At the beginning, I will talk about my PySchool journey a little bit since the majority in PySchool. I will not go into details here. Then I will talk about the foundation of language models just to make sure everybody here on the same page. After that, I will move to talk about the graph theory, especially GraphRAG. Then we'll introduce language models and agents. Then we will talk about how to use the graph in order to orchestrate multimodal collaboration. And this is mainly something related to some of the open source work I did. As said in the introduction, I'm studying master's at Illinois Urbana-Champaign. I'm data scientist at Vectra AI. It's a cybersecurity company. Also actively contributing to open source in GitHub. You can see my account here. I joined PySchool in 2019. It was really interesting activity because the school gathered people from all around the world. I had the chance to meet persons from different backgrounds. Also, at that time, I worked on a project related to Italian language from a company in Rome. But the interesting thing, my colleague was Italian, and all of us together managed to go through the requirements and deliver a model. At that time, it was a BERT model, one of the language models, to match candidates with the proposals. I don't know Italian, but using the embedding approaches just to get the most similarity words between each others and the help of my colleagues, we managed to deliver a successful project. At that time, at least from the analysis we did, we managed to save 80% of the client time in order to match proposals from candidates to tenders from the government. About the language models and our topic, just to make sure all of us on the same page, I will start with elevator pitch approach to talk about it in a simple way. For example, let's imagine you want to talk about the language model in one sentence until you reach the first floor in elevator. You can simply describe it as language model defines what can and can't be said in a language. And if you had the chance to talk about it a little bit more, you can go a little bit technical to say like it's captured the pattern in text, learning how words and phrases fit together. Also, like the way it's worked, it's tried to predict the next token in the sequence based on the context. Also, like it's look like something smart or something that might have conscious, but this is not the story. It's only a next token prediction or next word prediction in order to work with some of the language models we see in the market, like GPT-4 and Llama from the open source space. How the models work to predict the next token based on the context. For example, if we are in a sport context and we say the sprinter need to run the most, probably like the highest probability here going to be, for example, the word fast, not the code. And this is how the language models work. They only try to predict the next thing based on the context. But for example, if we are working in some development related to tokens, or token is going to be the code. So this is how the language models really work. They seen lots of words from the internet, and from these words, they started to learn what might be the next token. One way to interact with the models that we all use is prompting, and the idea of prompting, just giving some instructions to the model similar to the thing we did with ChatGPT, for example. That's the simplest approach. But we can take this further in order to enhance the results by applying something called few-shot learning. And the idea of few-shot providing some example for the models, how it should respond to your question. This will help to increase the accuracy a little bit. For example, if you are working in some genome sequence prediction, showing some previous genome sequence, how they look like, before asking your questions about one of them will make the results better. It's considered some kind of prompting, but with examples. The next level is retrieval-augmented generation, which called RAG. And the idea here to provide data source to the model in order to enhance the accuracy. There are many issues with the current models, although they look accurate, but if you look into the details, you will find some issues like hallucination, referring things not related to the topic, and RAG, the augmented generation, by adding a data source can help to mitigate this issue. All of these work to interact with the model without the need to change the weights or edit them. But if you want to take it furthermore, you can do something like continued training or fine tuning. And the idea here, if you have a training data and you want to provide some customization to the model, you can do this using, for example, supervised learning. You can provide, for example, an input. Let's assume it's a resume, and output a score if you are employer to say whether this resume match your criteria or not. If you give enough examples to the model, you can have a model that auto-score the resumes that received to you in order to give a high score to the things that match your criteria. As we said, that tuning is one thing called continued training, and the idea of continued training, you don't have to train everything from scratch. You can continue from some of the last weights available to the model. Okay, this is example how few-shot learning works and how it's helped to improve the accuracy. This is from the first paper, which is the first paper from OpenAI called Language Models Are Few-Shot Learners, or let's say the first paper related to the GPT. So this is GPT-1. Now we have GPT-4. The improvements come from few-shot learning. It's not going to be as high as this because the models now are more accurate. But this is example, if you get a basic model, to what level you can improve it even without changing the weights. So this is example when asking a question with 0 shots about the accuracy to some data sets, benchmark data sets. And the more examples you give to the models about how it should answer, the accuracy going to increase. As you see here, the accuracy increased dramatically up to some point, then it's reached a level of maturity where the level of accuracy increase become lower. So before starting the fine tuning, for example, or trying to edit the weights, you can try to show some examples to the models, see how the accuracy increase. If it's increased to the level you want, that might be enough. If not, that means your data set is custom. The model didn't see something like this before, and you have to do fine tuning to provide training data. And this is an example how you can tune the model to provide a better answer. For example, I wanted the model to describe an image related to that science topic, for example, supervised learning, regression analysis, and I wanted the model to give a style and to describe the relation between entities. If I ask the model to describe the image for me about this topic, and the reason I wanted to describe the image because I wanted to connect two models, one model that describes the image, another model that generates the image. This is one of the way to get like high quality images. Instead of saying supervised learning, generate to me the image, you give to the image model a description. So the first model, it can describe the image in many ways, like in infinite ways, they can describe the image, but I wanted to describe it in a specific way. So I give it two examples. Then I create some template about the next concept that I want to describe. For example, it says it's called language models. Then my model going to answer after the description and give me the image description based on the data science concept. This way, it really helped me to enhance the accuracy of the image because it started to describe it in my own style. Another concept to enhance the accuracy, it's called RAG, retrieval-augmented generation. And the idea here to provide your data source to the model. Yeah. To provide a data source to the model in order to improve the accuracy. So here's an example how RAG works. The user query comes to the language models, to the language model here, as we see. But I don't want the model to answer from the training data only, from the data seen during the training. I want the model to answer the data from my data source. I am a company, for example, I have some HR policies, and I want to make sure the answer related to my policies. So if the user query go to the model directly without the data source, it's going to answer anything from the internet, the data seen from the internet. But I can go through an embedding model, and the idea of embedding model, a model that generates a vector, and this vector can be used to apply some mathematical equations in order to get the most similarity from my data source. So I'm gonna get a vector here. I'm gonna apply it to some vector database where all my HR policies are stored. I will apply something called cosine similarity. I will show you how that's worked in the next slide. It's gonna give me the most relevant pages or items to my answers. That's gonna go as input to the model along with my question. This way, the model will provide an answer that's more accurate comparing to not having the RAG architecture that we see here. You can apply to this to GPT-4. You can apply it to the open source models like Llama or Gamma from Google. That's a general concept that can be applied to any LLM. And the idea of the similarity and the vectors. So you can look to the vector as an array with numbers that represent the semantic meaning of your data. And this come with direction. And based on the similarities between two vectors, for example, your question and multiple pages from the data source or from the HR policies, the lower the cosine distance between them in the latent space, the more similarity between the data stored in your vector database and the user question. And this is the idea of the embedding. You can do it using you can do the similarity using something called cosine similarity, or you can use it, do it using inclusion distance. Also, it's calculate the distance between two vectors and give you the items with the closest to your question. So this is what really happened behind the embedding model whenever we compare two vectors together in the database to get the closest items. You can have another arrow here. That's mean, for example, vector C, that's here. The distance or the cosine distance between your question is higher. So it's not going to return as the most closest item. That's an introduction, how language models work, how the embedding work, before going to some of the advanced topics like the graph. And here I'm going to work how to apply the graph to the RAG concept in order to improve the accuracy of the model furthermore, and what are some of the limitations related to RAG and how you can resolve it with the graph approach. Any questions before I jump to the GraphRAG? Feel free to raise your hand or ask in the chat. Cool. GraphRAG is something from Microsoft. It's an open source. And the idea is, before generating the embedding that we talked about, it's going to generate entities. Entities like items that describe your data. For example, it can be person, it can be a name of a place. That's the idea of the entities. Then it's going to draw relations between those entities before going to the details of your data. And why this is powerful, presenting the data in a graph, this will allow us to have a more holistic understanding how our data work before returning the answers to the model. For example, if we apply simple RAG, the simple RAG is going to return any related data. All of them might be related to the same theme or the same topic. It's not going to represent all our data. But in this example, this related to some episodes. Let's assume it's episodes from a series or episode from a story. If I want to ask a question, I want to get the most similar item from all episodes, like give me the general theme from all the episodes in this series, for example. And I have the text that describes every episode there. If I applied regular RAG, all of them might come from the same place, but because I gave the model a holistic understanding of the data, it's going to describe each episode, how it's look like, and this get the RAG into the next level. So why we apply it? If we want a holistic understanding of the data, if we want to get a hierarchical extractions of the information that's go to the model in order to provide answer from our data, it's work well with the question answer approach, especially for complex information. If you have simple information, regular RAG might work, but GraphRAG will work better with complex data with many relations. And if you represent the embeddings and some of the visual tools, this is how it will look like, representing the relations between entity. So the model first will generate the entities, then it's going to generate a description about all the entities and the relations between them. Then it's going to save that into a Parquet file where you can use it to get the data back to the model. GraphRAG is easy to start. It's something from Microsoft. So if you want to start with GraphRAG, you can install it as simple pip install GraphRAG. Then you have to create a folder called input. Save any data there, any text file you have it, just store it into the model. It shouldn't be something supervised. I mean something that's refined. Just put the data there. The GraphRAG is going to understand the relation automatically. Then you have to apply these two commands. This first command going to initiate the project settings, and and you're gonna find .environment file where you have to set the key for your model, whether it's an OpenAI model or any other model. You can custom it there. Let's assume you want to use something from Google like Gemma or Gemini, all of this supported. After you set up the model details, you can run this command that's going to generate Parquet files, and this Parquet file is going to include all the embedding details for your data. And to ask a question to the model, you can ask it this way: Python-m graph.query. You give it the folder where the Parquet file are available. Here is the root in my current terminal, for example. Then you will provide your question. This is, for example, this question related to some storybook that I created locally. There is some scientist that tried to do some experiment and did a mistake there. This kind of question requires a holistic understanding. This is why having the GraphRAG is a really good thing. So I asked, what is the scientist's mistake? And if you apply this locally, you will find the steps printed to you. Like at the beginning, the model gonna generate the embeddings from your question, is gonna relate it to all the entities, then it's gonna dig deeper into the entities in order to provide the right answer to you. And there is something in a GraphRAG called global and local. The main differentiation between them, the global, if you want ask something that requires a holistic description about your data, and if you want the model to dig a little bit deeper into specific topic, you can describe the method as local in order to answer something, for example, related to one person or one entity in our data. You can try to apply it using GraphRAG, apply it using the regular RAG. You will find like GraphRAG, especially with the holistic question, gonna provide for you more detailed answer. So that's related to using graphs in your data. Now I'm gonna take this a further step to tell you how to use graphs with your models, because we not usually, like, if you want to work with some advanced use case, you're not gonna work with one model. You might work with multiple models, like speech model, image model, multiple text models or language models. Some of them are tuned to some use cases, and you want to manage the relation between them. There are multiple ways to manage the relation between them. One of the ways, you can do it using graph by having multiple nodes and where each node represents an agent. But before showing you how to do that, just I'm gonna make sure everybody here understand what I mean by agents. And the idea of agents is breaking the problem into multiple steps, which help to reduce the errors and increase the accuracy. There are multiple papers that try to describe this. One of them called chain of thoughts. And the idea of chain of thoughts, it's related to one agent in the simplest approach. Instead of the model providing the answer for you directly, for example, let's assume there is a question that requires some mathematical answer. Instead of the model saying the answer 11, this paper tried to help the model to break the problem into steps, just describe what's the step, generate the answers, then give you the answer. Applying the chain of thoughts to your data help to enhance the accuracy. As we see in this example, there is another question. It's like a puzzle question. The model answered incorrectly at the beginning, but when they applied the chain of thoughts and the model started to describe the problem before give you the answer, that's helped to increase the accuracy. So it's about breaking the problems into multiple steps. And one reason this helped to reduce the errors, because as we said, the models work to try to predict the next token. So the more context available about the next token, the less the errors are going to be presented. If you want to apply chain of thoughts to your data, there are two tricks. The first trick, if you are using zero shot, like you only doing prompting, at the end of your prompt, you can say, let's think step by step. Only by providing this statement, you will nudge the model in order to describe to you the steps instead of giving the direct answer. Another way to apply chain of thoughts using few-shot learning by providing some examples. And in these examples, you provide the optimal answer by breaking the problem, how the model should break the problem before providing the answer. If you did this, in the next question, the model gonna answer in the same template you provided to them. Then, if you want to take the agent into next step by applying two agents working together or three agents working together, there is a concept that's called self-reflection. And the idea here, you will have two models, one model that provides the output and one model that's gonna do critique. And the idea of critique is validating the answer and make sure it's as expected. For example, by providing an external tool. Let's assume you ask the model some question, the model give the output. Before provide the output to the user, you can verify through some of the tools. For example, verify it against Wikipedia or your data source through another agent. Then the other agents will tell the other model whether the answer is correct to provide the answer to the user, or it should go through another iteration in order to verify the information and reach the most optimal answer. And this way, by applying self-reflection, having two models working together, that will help you to provide more production-ready setup with less errors. I'm gonna pass through this about self-reflection because we talked about it, how two models work together. The first model going to provide the answer, the other model gonna use some tools, and I will tell you some of the tools you can use it to apply the self-reflection. One tool is Llama Index. Llama Index is focused on the RAG. It's really worked pretty well with RAG. Also, it provides some tools to apply the graph on your data level and to orchestrate multiple models working together. Another popular tool is LangChain, and LangChain focus more on agents and how to let multiple agents working together and providing some external tools. For example, if you want to connect to external database or you want to get information from the internet, instead of implementing all of this from scratch, you can use LangChain ready tools. And the third thing is IntelliNode, and this is something I contributed into building. IntelliNode focus on using the graph approach in order to enhance the multimodal collaboration. We've seen how the multimodals work in our data, but I wanted to take this furthermore and to apply the graph approach in order to let multiple models work in a graph way by having nodes and edges between them. And why I did that? Because sometimes the relation might be so complex. So instead of applying a new concept or a new architecture to orchestrate all those agents, you can use a graph and then navigate the graph using, for example, breadth first or depth first, some of the popular graph navigation techniques in order to move the input from one model to another. If you want to start using this in Python, you can pip install Intelli. This will let you ready to apply multi-model collaboration. You can apply it to open source models or some of the models behind API like GPT-4. I wrote an article about this concept with Toward That Science. It's called Graph Theory to Harmonize Model Integration. And the idea is, if you want, for example, one image model that's gonna work with another language model that's gonna work with a vision model, with a speech model, and you want to give more senses to the model in order to see, talk, and hear the word, you have to orchestrate all those models working together. This is one approach to apply this and make you closer uh, to the general AI. Another way, you can build one model that includes all these capabilities, but it's going to be complex and there are lots of research trying to adjust this. But until we have one model that understands all the input types and give you all the output types, orchestrating the multi-models together gonna give you all of these capabilities in one solution. And you can navigate all these models using a graph. In 2023, it was about having single model. We started to hear about many of the language models, but in 2024, the trend now and many of the companies started to release multiple models that work together and do the interactions. But some of those multimodal hidden behind API or some of the release one doesn't give you all the tasks. This is why if you orchestrate those models for your use case locally, you're gonna have all these capabilities to help you in your use case. This is one example just to show you why we want to apply the graph concept and how it's going to help us. For example, here, I'm talking about a use case that requires 3 agents. One that's going to scan your data, another agent that should include a vision capability, another agent that should analyze your task. Based on self-reflection, we've seen that breaking the problem gonna give you a better result. This is a graph approach. For example, we have multiple nodes, each node going to present an agent, and then the edge going to tell the framework how to move the data from the first agent to the second, instead of inventing all these details by yourself. This is an example about drug discovery. Let's assume you are a pharmaceutical company. You have lots of data. You're gonna get the first model that scan all this data and highlight from it some of the protein links to specific disease from all the research you did so far. So the first model going to focus only on this task. It's gonna extract all this information. It's gonna use it to 2 models. One model that's gonna analyze the tasks, another model that's gonna take all the images from those information and gonna describe it to the task model. Because if you are working on a protein, we want to understand what's the protein structure, usually that is presented in an image. So the vision model, for example, some fine-tuned vision model, gonna describe the protein or the DNA sequence in order to give a better analysis at the end, getting the text information, the analysis of the DNA sequence. Another model can draw the relation between the disease or provide some kind of chemical compound. You can do it in one model, but if you add all these tasks in one shot to this model, there is higher chance of having error than having multiple models, each one specialized in one task. This is how it works as a visual. For example, I have here, let me zoom to this image a little bit for you. For example, you will have multiple nodes. Each node, you're going to assign one task to that node. Then you're going to give it an agent. For example, here, I assign to task 1 an open source model from Google that's called Gemma, or the one behind the API that's called Gemini. You can assign any of them. For example, you can create task 2. It's going to be another node in the graph. And you can assign to it, for example, one of OpenAI models. Each one of them going to specialize in their own task. And in order to navigate the data from one model to another and manage the dependency, This is how you do it through edges. There is an edge from here to here. That means task 2 cannot start until task 1 gives you the answer. However, task 2 and task 3 can work together when task 1 finished. So this is an example why having a framework that's work in a graph way will help you to reduce the complexity. If you want to implement all of these details by yourself, it's going to take multiple pages. But if you do it using a library like IntelliNode, all you have to do is to create the agent, what kind of agent you want to work with, for example, text, image, or speech. You can define the provider of this agent, whether it's OpenAI, Google, and give the model parameter. For example, here I work with OpenAI as GPT-4. You can work, for example, with Stable Diffusion as agent 2, for example, that's called image agent. Then you have to define your task, which is going to be the task in the node. For example, here's a task that say, write a blog post about climate change. This is one of the tasks. And I will assign the text agent to this task. So my agent going to focus only to write the blog post about climate change. The second agent can be focused only to generate, for example, marketing materials like images and keywords. Then you have to create another agent and assign it to that task. And this is how you can draw the relation between them. Once you create the task, you can give it a name. Here, for example, I have a title task, a content task, keyword, theme, and image task. I want to create a blog with marketing materials and so on. Each one focus on one task, or each step focus on one task with an agent assigned to this task, as we see in this step. Then we can draw the relation between them. You will create a dictionary, as simple as this, and you say, the first thing, I want to start with the title task. I want to generate a title for my blog. After the title, I want to generate the keyword and the content. Then from the content, I want to generate the theme. And from the theme, I want to generate the image. This is how you describe it. You don't have to take care about the complexity of dependencies, because IntelliNode gonna generate for you all the nodes as you've seen here with the assigned task and the assigned agent. For example, in the image task, we assigned stability, which is a stable diffusion model to generate images. And because this, the only node that doesn't have dependency, our framework gonna take care to start here, then move to output from this task to this one, and navigate the graph step by step. So this is one of the reasons why having a graph concept to manage the agents might help you to implement more complex application. And this is another use case also described as graph to generate data science concepts. That's work with open source model like Gemma. Also, the framework gonna take care to load the model offline for you from your local machine, or if you want to load it from an API, all of this gonna work together. For example, a simple task, you can use open source model. For more complex tasks, you can use GPT-4 model. I prepared some lab, but I'm not gonna go through it just for the time. I'm gonna share the link with you later if you want to apply this assistant that generate teaching material using open source models. The takeaways from today's talk, just to summarize what we said, you can improve any model accuracy by applying some of the advanced techniques. For example, if you shot learning, providing some examples to the model, applying the RAG by connecting your data source to the model, that's going to take the language model to the next step. Fine tuning, if you've seen the few shot learning or RAG didn't provide the answer you look for, that means your data case or your use case is custom. So you can apply fine tuning at this time. The agents is the next step to reduce the errors by breaking the problem, and you can apply two techniques: chain of thoughts and self-reflection. Finally, if you want to do multimodal collaboration, you can do it using multiple libraries like LangChain, IntelliNode, or Llama Index. We talked today about IntelliNode, which introduce a technique to apply the multimodal collaboration using a graph approach. That's all about it today, and I want to give the chance for questions if any of you have questions about any of the topics we discussed today. Thank you. Yeah, please go on. Mehran. Do you have a question or just sharing? Yeah.
Hi, Ahmed. I have a question.
Hi.
I'm Ishan. So first of all, really nice content. It was really informative. Um, I have a question like the GraphRAG. I am recently exploring that as well.
Cool.
So my question is, does it work with, does it support the open source models right now, or does it just support GPT or some of the models offered by Google?
Yeah, this is a good question. Once you generate the settings from GraphRAG, you're gonna have some YAML file. If you open the YAML file, by default, it points to OpenAI. But if you use one of the services, for example, there's a service called Grok. It's one of the fastest service to provide for you open source model. So if you change the URL to Grok and the API key to Grok OpenAI key, you can work with some of the open source models.
Okay, got it. Thank you.
Yeah, thanks for this. Yeah, correct. Llama works pretty well for local LLM. Also, by the way, Keras, the latest version from it, allow you to load many of the open source models. Okay, great.
So I have a question. Okay, great. Rui, go first.
Thank you, Rich. Hello, Ahmed. It's very
Hi.
interesting topic. I used Cypher from Neo4j before, and today you talk about the GraphRAG. I checked it. I think it's recently published on GitHub. I just want to know if you have any experience using the GraphRAG, and have you compared it with the Neo4j Cypher graph language? I think those Neo4j Cypher, they have some integration to the long chain framework. So what do you think each of the implementation? And I'd also like to know, for the Neo4j Cypher, they usually argue like the graph is a knowledge graph built from those maybe tables or some passages. They are providing a grounding truth for the large language model. So in your use cases, how is it the same? Like use those knowledge graphs to provide a grounding truth? And is there a way to force the large language model to use that grounding truth rather than omit it? Because from my understanding, even though I provide something, maybe there's some possibility the large language model still just ignore it. What's your idea about it? Thank you.
Yeah, that's a really good question and a note. Actually, I didn't try the Cypher library that you talked about, but at least from GraphRAG, it's worked pretty well with me when I wanted to talk about something that's uh, related to holistic approach in my data instead of precise answer. I had an issue with RAG, at least from my use case, because it's work to return the most relevant item if I want to talk about something that describe all my data, all the return information come from, for example, one chapter in the book, because maybe that chapter, all of the pages from the chapter are the most relevant to my question. But when I tried the GraphRAG, at least in the use case of asking a question about all the data, it's really managed to give me a breakdown of the data, how it looked like, then it started to talk about the answer. So at least this was my use case. About your question related to ignoring the provided data, yes, this is a common problem. You can mitigate it a little bit using the system messages. It worked with me sometimes, like for example, I tell the model in the system message, please don't answer anything outside the context. And then when the data return, I give it a title that's called context. In this scenario, at least I seen the model not providing answers outside of it. For sure, like you can break this, but in the general case, providing a system message will help to mitigate the issue.
Thank you, Ahmed. Do you know how does the GraphRAG query that query the graph it builds? And do you know do you need to provide some relation, some specific restriction? What kind of graph you are going to build, or it's just built by itself?
Yeah, if you look to the generated files, you will find some prompts there, and these prompts control how the entities are generated, how the summary is generated, and how the relations look like. The good thing, as you said, like GraphRAG released recently as open source. So now like Microsoft give you the access to all these details. So you can go to the prompt, try to play with them before generating the entities. That's help to custom the use case to your scenario.
Okay, thank you very much, Ahmed. Definitely, I will play for a bit, to see how
Cool.
it can work. Yeah. Thank you.
Great question. Thank you.
Great. Anyone has any other questions to ask? We still have a few minutes. Okay, in that case, I have a question to ask. First of all, I really like your presentation, especially the multimodal part. A lot of content, on the internet doesn't seem to cover it that much. I had a question about evaluation. So when you're designing such a complex workflow consisting of several agents, how do you begin to evaluate such an application? Because it's quite a complex task in itself.
Yeah, that's a great question, because evaluation is a problem. For example, like there some papers describe one way to evaluate by using a model that do the evaluation, but if you look to it really, like even the model that do evaluation might do mistakes. So like you ended up evaluating with a model with some percentage of mistake that evaluate another model that do some percentage of mistake. Some of the ways, like building a benchmark that's work pretty well. However, that's expensive sometimes to build the data for use case. But the good thing, once you build it one, you can use it thousands of times. At least from some of the work I did, usually like I work with some either outside freelancers or from company freelancers just to refine some benchmark about the optimal answer. Then once the model generates the answer, I start to compare it with the benchmark in order to see how relevant it is. That's worked with me pretty well. And that might be the most practical part. Another approach, working with humans. For example, I worked before with the hospital, and I worked directly with the doctors in order to evaluate how the results look like. Because if we work with the patients, I want a doctor that tell me whether the answer is good or not. So it depends, for example, on the sensitivity. For example, if it's sensitive place like hospital, you might need a human to evaluate. But if you are working with some data that's might accept a small level of error, you might let another model evaluate, or in the middle between a human and the model, the benchmark data that you prepare it one, it's a good approach.
Great. Yes. Yeah. Sounds like a plan. Thank you. Thank you for that.
Cool. Thanks for the question.
Okay. If no one else has questions, I think we can end the talk now. Ahmad, thanks a lot for your time, and it was definitely a very informative talk for all of us. And we hope to implement some of these things and stay afloat in the LLM world for the days to come. And just as a closing note, I would like to say that, yes, the presentation would, you probably will be given the recording anyway on YouTube. So I think you should be able to, get whatever content of interest that you have from there. And I guess we will notify you when it is up on the channel, iSchool's YouTube channel. So yeah, besides that, please feel free to follow us on Twitter, LinkedIn, and Instagram. We do have an active presence there, and we will keep posting about interesting things on LLMs and also a lot of useful content on tech, the AI space, and more tech talks to come. And with that, I will say good night or good evening to everyone.